All right. I'm gonna do a quick video on parametric equations and kind of eliminating the parameter. And we know most of the time, if you want to put this in like a rectangular form where you just have like an x and y, like a traditional equation, you just kind of isolate the t over here, right? And then plug it over here, and you have your equation, right? Well, it gets a little weird when you get the trig stuff in here. So I just want to show you a couple examples of how to do this, and we'll do a couple easy ones. Do it the hard way, easy way. I'll do the trig nerd way to do it, and the easy way to do it. So I want to start off with the traditional method, and just what we're going to do is we're going to isolate this t, bring it over here, and get an equation. So if you look here, we got x equals 4 cosine t, y equals 4 sine t. So if I solve for this t, you divide both sides by 4, right? So you get x over 4 equals cosine t, and t represents like an angle here, right? So if you want to solve that angle, if the cosine of t is this ratio, you'd have to take inverse cosine of x over 4 to get t, right? Well, now come over here. Whenever I see t, I put this in, right? So you get y equals 4 sine of inverse cosine of x over 4. And you're looking at it like, what am I supposed to do with this? So here's what's happening here. So basically, the answer to this is some angle, and we want the sine of that angle, right? So the way you could do this is, what you're saying here is you have an angle with a cosine of x over 4. So if I drew a quick little reference triangle right here, right, and say this is t, right? Well, this is t, then adjacent or hypotenuse would be cosine, right? And the answer to this is this angle. Well, we want the sine of this angle. So if we look at this, I'd have to do a quick little Pythagorean to solve for this side right here. But if you took this squared, which is 16, and this squared, which is x squared, 16 minus x squared, you take the square root, you get this. Square root of 16 minus x squared. And you could do the Pythagorean theorem on that, but trust me, that's that side. So if I want the sine of this angle right here, right, because this represents angle, the sine of this angle would be this over this, right? So watch. What you get is you get y equals 4 times square root 16 minus x squared all over 4, right? And what do you notice is going to happen with those 4s? Well, the 4s go away. Let me erase that real quick. The 4s go away, and you get y equals the square root of 16 minus x squared. And when you square both sides, you get y squared equals 16 minus x squared. Add the x squared over. X squared plus y squared equals 16. Oh, sorry. Can't see that. X squared minus y squared equals 16. Okay. So this is our rectangular equation. Okay. And if you like trig as much as I do, that way it's really fun because you get to explore cosine, sine, inverse, draw a reference triangle, all that good stuff. But basically, you end up with a circle. Okay, x squared plus y squared 16. That's a circle with 0, 0, and you got a radius of 4, right? So you might say, well, Mr. Winslow, that's way too much. I don't want to do all that. There's got to be an easier way. Well, the good news is there is an easier way, okay? And I'll show it to you real quick. But the easier way would be, if you look at these two equations, right, we have a cosine and a sine. Well, luckily, we have a relationship between cosine and sine, okay? The relationship goes like this. It goes sine squared of any angle, in this case t, right, plus cosine squared of any angle would equal 1, right? Okay, that's just a Pythagorean identity. Well, if you solve for cosine here, right, if you divide by 4, cosine would be x over 4, right? So you could put x over 4, substitute right here, square, right? Sine here would be, you divide the 4, sine would be y over 4, right? You square it, equal 1. And now watch this. You're going to have the exact same thing we had a minute ago. When you square this, you get y squared over 16, right? you get x squared over 16, and you get 1. If you multiply everything by 16, you get y squared plus x squared equals 16, just like we had before, right? So that might be a little easier, but maybe now you understand why, you do all that. You could literally draw those triangles, eliminate that parameter, and get that same thing. So this set of parametric equations basically gets you a circle, okay? So another one real quick, if you look, pretty easy one. Let's see, we have x equals 4 secant t, y equals 4 tan t, okay? So it's kind of the same deal, but you got a secant and a tangent. Well, you could do the whole reference triangle, solve for t, whatever, but the relationship between secant and tangent is 1 plus tangent squared equals secant squared. So by just solving these for secant and tangent, you could easily solve this, right? So you could divide that by 4, right? So secant would be x over 4, so I could do a x over 4 over here. And here you have, if you divide that 4 over, you get tan is y over 4, so you get y over 4 here, plus a 1, so you get 1 plus y squared over 16 equals x squared over 16, very similar to the other one, right? And once again, if you multiply everything by 16, you get 16 equals, or excuse me, 16 plus y squared equals x squared. Those 16s cancel out, right? And in this case, you'd get, if you subtract that over, you get x squared minus y squared equals 16, okay? So this would be, if you look at that, x squared minus y squared 16, I believe that's a hyperbola, okay? But, yeah, same thing, right? Okay, so you're welcome to draw the triangles or whatever. Really dive into the trig part of it, but you could also just kind of pull on some of these maybe trig relationships that we've learned over the course of the year, like the Pythagorean identities, and you could easily get some of these answers, okay? So keep that in mind, and that might be an easy way for you to get those answers, all right? So hope that helps, and y'all have a great day.